Density 2. I'd first like to go over the three density equations that we established during the first lecture on density. The first equation says that density equals mass over volume, where mass is given in grams and volume is either given in milliliters or centimeters cubed. Density, therefore, is given in grams per milliliters or grams per centimeters cubed. The second equation solves for volume, and it states that mass divided by density equals volume. And the final equation says that mass is equal to the quantity of volume times the quantity of density. Very well. This is our very first pair deck activity. It should be pretty easy. Density is a measurement of how tightly packed the molecules in a substance are. Imagine each dot within each box is a molecule and label the relative densities of each box. 3 would be high density, 2 medium density, and 1 would be low density. What would this one be? Good. Now let's try this one. And this one. One thing that we know about density is that substances, solid or liquid, are less dense, will float in liquids that are more dense. Using the previous exercise, rate the relative densities of the states of matter. Put a 3 next to the word if you think it's high density. Put a 2 next to the state of matter if you think it's medium density. And put a low or 1 if you think that this state of matter is low density. Very good. We will now go over your density lab. Your density column lab included substances with different densities that would stack up on top of each other rather than mix. Each element in the periodic table has a characteristic density, and we can use this to identify them. Very well, let's look at our practice problem number 1. A cup of gold-colored metal beads was measured to have a mass of 200 grams. By water displacement, the volume of the beads was calculated to be 22.57 centimeters cubed. Given the following densities, identify the metal. We start off by identifying both the mass and the volume. Those are the two variables that are given in this word problem. Mass is equal to 200 grams. Volume is equal to 22.57 centimeters cubed. Density, if you remember correctly, is mass divided by volume. Therefore, to find the density in this problem, we will take the 200 grams and divide them by 22.37. Our density then is 8.940545 grams per centimeters cubed. But we have to provide the correct number of significant figures. This is a division problem. Therefore, we're looking at the total number of significant figures. The number 200 with a decimal has 3 significant figures. The number 22.37 has 4. Therefore, we need to round our number to 3 significant figures. Our density then is 8.94 grams per centimeters cubed. If we look at the table now, and we try and match up the density, we see that the gold-colored metal beads are made of copper because they have matching densities. Practice problem number 2. An ice cube measuring 4.111 centimeters by 4.111 centimeters by 4.111 centimeters has a density of 0.917 grams per milliliters at 0 degrees Celsius. What is the mass? Very well, we identify the variables first. Density is equal to 0.917 grams per mil. The volume can be found by multiplying the length times the width times the height. So we take 4.111 centimeters times 4.111 centimeters times 4.111 centimeters because these are the dimensions of the ice cube. Our volume is then 69.48 centimeters cubed. And if we remember correctly, 1 milliliter is equal to 1 centimeter cubed. Therefore, the volume is 69.48 milliliters. Our mass can be found by taking density and multiplying it by volume. Our mass is equal to 0.917 grams per mil times 69.48 mils. We get 63.71316 grams. But we have to account for significant figures. 0.917 is 3 significant figures and 69.48 is 4. Therefore, we need to provide 3 significant figures. Our final answer is that mass is equal to 63.7 grams. Problem number 3 states that gasoline, or scientifically known as isooctane, is a nonpolar liquid that will float on water. 700 grams of gasoline is spilled into a puddle of water. If the density of gasoline is 0.665 grams per milliliters at 21 degrees Celsius, what volume of gasoline is spilled? First, we need to identify our variables. 0.665 grams per milliliter is our density, and our mass is 700 grams. We will therefore be using the equation volume is equal to mass divided by density. We substitute in our known values, and we get 700 grams divided by 0.665 grams divided by milliliters. Our calculator answer is 63.71316 milliliters. We then look at significant figures. This is a division problem. Therefore, we need to provide the least amount of significant figures. 700 grams has 1 significant figure, and 0.665 has 3 significant figures. Therefore, our answer should be Therefore, the volume should be 60 milliliters.